Okay, hello. Let's start with Python week 6. So today we're going to go over lists, tuples, sets, and dictionaries. So let's start off with lists first. So why are lists important? Why are we even doing this? So imagine this is a scenario. Imagine you are a teacher and you're inputting the scores of every student in variables. So you have student 1 and their score on test 1 is 38. And then you have student 2 and the score on the same test is 79. And it goes on, and then you have those same students again, but they take a different test. So you have student 1 and they have score test 2 and they have a 99. And then you have student 2 and they score on test 2 a 21. And you just have all these variables for every single student, and for every single test they take, you need a different variable. This would take forever. This is why lists are important, and they make the job easier. You can use lists to hold multiple values in one variable, and it makes your code more efficient. So they would be like test 1 scores would have, and then you'd have brackets, and you'd have a list of scores. And you would just have each student 1, student 2, you just have them in the same order every single time. And you could assign each student a certain number. So what are lists? So the definition of a list is that they are an ordered data structure that hold multiple values. And you'd create a list by having a variable name, an equal sign, and square brackets, or you could have a variable name, an equal sign, and then a list, and then in parentheses, and then inside you would input your values. So either way is fine. Here are some examples of lists. So the first one, we have a list called continents, and inside we have Africa, Asia, North America, and Europe. And if you noticed, these are all strings, and each one has their quotations, and outside of the quotations, they're separated with commas. And if you print out continents, it just prints out each of the values in the square brackets. And here you have another list of integers. So you have repeated values equal, and then you have 4 ones. And these don't have quotations around them because they're integers and not strings, but each one of them is still split up by commas. And so if you print them out, they just print out exactly how you wrote them in square brackets and split up with commas. Now, your lists don't have to be just all strings or all integers or all doubles. They can be mixed. So if we have weird list equals, when you have 1, and then you have, which is an integer, and then the string 2, and then the double 4, and then we had the variable 4 in there. So 4 is equal to the digit 4, the integer 4. And you can put in the variable, you can put variables into lists. And if you print it out, you just get the value of that variable. So some actions you could take with lists. You can find the type. So you can find the type of list and you just print and then type parentheses and then the name of your list. You could find the length of the list, and that's how many items are in the list. And so an item, Africa would be an item in the first one, Asia would be another item, North America would be another item, Europe would be another item. And so in total, this list has a length of 4 because they have 4 items. They can also be called elements. Same thing with the repeated values. These all have 4 items or elements in their list. So if you did print and then len, L-E-N, and then parentheses, and then the name of your list, it prints out how many items are in that list. So for the first one, if you did print ln, L-E-N, and then continents, you'd get the number 4. And then you can also add items to a list. Now, if you use list.append and then whatever your item is, you can put in a double, an integer, a string, another variable. It would append that to the end of the list. So another thing that's important is the indexes. So indexes in lists are very similar to indexes in strings. The first item or element starts at 0 and it goes on positively by an increment of 1. So apple is at index 0, mango is at index 1, strawberry is at index 2, banana is at index 3, and guava is at index 4. And so you can call each specific value by using the index. So if we did fruits, that's the name of the list, and then square brackets and index 0, that would be equal to apple. And the most important thing to remember is that indexes begin with 0. We don't start at 1, we start at 0. So next we have tuples. Now, tuples are very similar to lists, except they cannot be changed. Tuples are an ordered data structure that can hold multiple values, but unlike lists, tuples cannot be changed. This is also called immutable. So we create a tuple by having the name of the tuple and then an equal sign, and then parentheses, or we have the name of the variable, an equal sign, and then tuple parentheses. So down here we have some examples. We have tuple 1 is equal to, and we notice we have parentheses, and it's written very similar to a list. You have, for an all strings tuple, you have quotation marks and then whatever your string is. Then outside the quotation marks, everything is split up using parentheses. Here we have the second one, tuple 2 is a tuple of integers, and we don't have quotation marks because these are all integers, but they're still separated with commas. And then tuple 3 holds Boolean values. Lists can also hold Boolean values. We didn't have an example of that, but that's totally possible. The only thing you have to know is when you make the tuples, you have to use parentheses rather than square brackets. And we can print these out, and they would print out just as we created them. Here are some more examples. This tuple, and then you have all these strings, and it looks like these are multiple strings. And then we have some indexes, tuple 2, 3, yeah, all this stuff. And now we can start getting into sets.
All right, so sets are different from lists and tuples. So like sets are unordered. So sets, like if you have like a certain amount of values every time, like it's not the items inside the set, they don't have indices or indexes. And then the way you create a set is just by calling the set function, as you can see here. It's just my set equals set, then 2 parentheses, and that creates a set. So here are some examples of sets. So as you can see in the first 3 images, the code is all the same. It's a set with apple, banana, cherry, orange, blueberry in that order. But every time you go to print it, the order changes because the sets, they don't have an order. They're unordered. So they're going to come out like completely randomly. And then in the bottom, it shows some operations of the set. So sets are useful because with lists and tuples, you'd have to go through like every single item in the list or tuple to see if a certain item is inside of it. But with sets, since they're unordered, you can just ask the program like, is this item in the set? If it is, it'll return true. If it's not, it'll return false. So you can see here it's going through whether an apple is in the set. So then you can return a Boolean value. It's just like, is apple in the set? Is like I guess an operator that asks like, is this item inside of this set? And if it is, it'll return true. If it's not, it'll return false. So as you can see, apple is in this set, apple, banana, cherry. But when it asks, is blueberry in the set, like it can just determine that blueberry is not in the set very quickly.
Okay, dictionaries. What are dictionaries? Dictionaries are an unordered data structure that stores data in a key value pair. How to create a dictionary? Is that put the value and use curly brackets, or you use the dict function. So here are some examples of dictionaries. So in the first one, this is a dictionary, and then you print the key value pair for brand. And then in the second one, it prints the whole dictionary in the console.
So we're going to start with an activity. I'll do the first two, where the first one is write a program, Python program to sum all the items in a list. So we're going to do that right about now. So in order to sum everything up, we're going to first create a list, and then we're going to create a variable to hold the sum, And then we're gonna iterate through each item in the list and then add each value to that variable that we created earlier. And then lastly, we're gonna print out the value. So let's create a list. We'll call it my list. And we're going to keep the numbers simple. We have 1, 2, 3, 4, 5, and then we'll do 6. Now we'll create a variable called sum, and we'll set it equal to 0 because it holds a total of 0. Now we can iterate through each item in a list by doing for I in and then my list. So what this does is it goes through each one of these indexes. And now we're going to do sum equals sum plus I, or instead of writing all that, we can do sum equals plus equals I. And then we can print out the value of sum. So if we do this quickly, it should print out 21. And if you do the math in your head, this does come out to be 21. Now, the second thing we can do is write a program to multiply all the items in the list. Now, this is very simple. We can just nothing changes here except for this line. We can just change it to a star for multiplication. And see, it's because it's 0. Now, the only other thing that we have to change is we have to change this sum value, or really we should change it to product equals 1, because if you multiply anything by 0, it'll come out to be 0. And so we're going to start off with 1 instead. Product, and now we're going to print out the product. And if we print this out, we get 720. That's how you do those. Now,
All right, so now I'm going to show all of you guys how to do the next 3 problems. So the max function, there's a slow way to do it. There's a fast way to do it. The slow way to do it is you can just like go through every single element in the list and check if it's larger than the previously largest element. But the faster way to do it, there already is a built-in function into Python that allows you to find the maximum of a list. It's just called max. Then you just put in like max R1 and it'll automatically find the maximum number in the list. So as you can see here, if you just run this, you can see R1, 10 is the largest value. We should print that as well. So you can see the output. If you do this, if you run it, it'll just show you 10. So the next problem that we're going to go through is to check if a list is empty. This is a function. You guys will learn about it next week, so you guys don't have to entirely understand what it is, but this is just a way so I can use the code without having to type it out again. So I'm just going to have, so in this function, I'm just going to have like an if-else statement. Just only if. Here's another function for lists. It's called len. It tells you the length of the list. So if like length of the array equals to 0, then that means it's empty. So you're going to print list is empty. And then like if it's not 0, you can just have an else statement, then print list is not empty. So here you can see my second array, it is empty. My third array, it is not empty. So when I run this, it should tell us the first line it should print list is empty, and the second line it should print list is not empty. And there you can see. And then finally, we're going to learn how to add a list to another list. In Python, not necessarily other languages, when you're adding a list to another list, you can just like have a plus equals. And that just automatically appends all the items in the list to the end of it. So first I'm going to print the first array just to show you what it looks like before. And then I'm just going to add, like do the plus equals on R1 with R3. And then I'm going to print R1 again to show you the difference. And there you go. You see it's 6, 2, 10, 3, 7. Then it adds on the 1, 2, 4, 8 from the third array.
All right, so that was our activity. I think here we have an example of the first problem. I do want to note that this does still work. I think this takes a little bit more programming. So what they did here is they went through they figured out the length of the list, and then they created a range using it. And then using each index, they started at zeros for index 0, and then they continued on this range, and then each time they used the indexes to get the value, and then they added it to the total. So this still works, but the way we did it, we just went through, you can just iterate through each item in a list. You don't have to call each and every single index, but this still does work. So that's all we have for today. Thank you so much, and we hope to see you next time. Okay, I stopped recording. And I should start that.
It's still recording.
Is it still recording?
It says it's recording on my screen.